second part, second section, zeros and poles. First, look at example 1. Suppose that two parts. First is A. Two functions P and Q are analytic at a point G naught. And second, B. P of G naught is not equal to 0 and Q has a 0 of order M at G naught. Then the quotient P of G divided by QG has a pole of order M at G naught. The theorem can be easily proved by using the previous theorem in the previous section. Let P and Q be as in the statement of the theorem here. Since Q has a 0 of order M at G naught, from theorem 2 in section 82, that we have this, there is a deleted neighborhood of G naught, throughout which Q of G is not equal to 0. And so G naught is an isolated singular point of quotient P of G divided by Q of G. Theorem 1 in section 82 tells us Q of G can be expressed by this form G negative G naught to the power of M times G of G, where G is analytic and non-zero at G naught. And this enables, with this, we can write the quotient P of G divided by the Q of G is equal to, here Q of G, here Q of G is replaced by this left hand side, and we get this, where pi of G is defined by P of G divided by G of G. Since pi of G is analytic and non-zero at G naught, by assumption P and Q are analytic at a point G naught, it now follows that from the theorem in section maybe 80, this typo, that G naught is the pole of order M of the function P of G divided by Q of G. Let's look at example 1. The two functions P of G is 1 and Q of G is G times e to the G negative 1. These two functions are entire. It is easy to check it. And we know from example 2 in section 75, Q of G has a 0 of order M is equal to 2 at the point G naught is equal to 0. Hence, it follows from theorem 1, just look at here. The quotient P of G divided by Q of G is equal to P of G is 1 and Q of G, G times e to the G negative 1. And we get this. Has a pole of order 2 at that point, which is the theorem. Okay. This is quite easy example, the apply theorem 1. Next, theorem 2. Let two functions P and Q be analytic at a point G naught. If these conditions hold, P of G naught is not equal to 0, Q of G naught is equal to 0, and Q prime G naught is not equal to 0, then G naught is a simple pole of the quotient P of G divided by Q of G, and residue of this function at G is equal to G naught is equal to P of G naught divided by Q prime G naught. Okay, let's prove it. First, we assume that P and Q are given by this. And to satisfy with this condition, then we let's observe that because of the conditions on Q, the point G naught is a 0 of order m, which is equal to 1. Okay, this from this condition, we get this result. The point G naught is a 0 of order m is equal to 1 of that of G here. According to theorem 1 in section 82, we just look at. We have this Q of G because G naught is a 0 of order m, so can be expressed by this G negative G naught times G of G, where G of G is analytic and non-zero at G naught. Furthermore, theorem 1 in this section tells us that G naught is a simple pole and of the function P of G divided by Q of G, because we just check it theorem 1 here. Order m is equal to 1 with this conditions, and the expression 1 for the function P of G divided by Q of G, the proof of that theorem becomes this, because Q of G is this, just replaced G negative G naught is replaced by this, Q of G is replaced by this, and pi of G divided by G negative G naught, where pi of G is defined by P of G divided by G of G. G of G comes from this factor. Since pi of G is analytic and non-zero at G naught, we just evaluate this function with G naught. P of G naught is not equal to 0, so numerator is not equal to 0. And pi of G consists of two functions P and G which are analytic at a point G naught. So pi of G is analytic at G naught. We know from the theorem in section 80, this is equal to this. Here pi of G naught here is equal to P of G naught divided by G negative G naught, but G of G naught is equal to Q prime G naught. Q prime G naught, here we can evaluate it by compute the derivative of QZ. Q prime G is the first part, the prime of the derivative of the first part times G of G plus and G of G naught times G G prime G. Okay. Then we insert G naught for the variable G here. Then this term is 0, and this term is 1 unity. Then we get G of G naught. So Q prime G naught is equal to G of G naught. So we get this, and so expression for the text, the form 2. Okay, this form.